أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سوف نأخذ درس مهم جدا، تمارين على الاتزان العام. طبعا احنا عارفين ان الاتزان العام ده فيه شرطين عشان يكون فيه اتزان عام: مجموع الجبري لحاصل الاكس والواي او السين والصاد يساوي 0 ايكوال 0 او ايكوال 0. تاني حاجة مجموع العزوم حوالين أي نقطة في المستوى برضه بتساوي 0. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static. Exercise in an equilibrium or general equilibrium. Dear student, look at the first example. Exercise in equilibrium. First example, uniform rod of weight 15 Newton raised in vertical plane. Dear student, what do you mean of uniform rod? Uniform rod, its weight in midpoint of the rod, with one end on a rough horizontal floor and the other end on smooth vertical wall. If the rod rests in limiting equilibrium when its inclination to horizontal is equal to 30 degrees. What is the required? Find the coefficient of friction between the rod and the floor and find the reaction of the wall on its end. Solution. Look at AB equals to L, the weight, the normal reaction R1. The normal reaction to R2, the force of magnitude force MR1. R2 equals what? MR1, this equation of an equilibrium. And R2 equals 15 times mu, because R1 equals 15. Look at R1 equals 15. Why? Because reaction at point A, R1 equals weight of the rod or uniform rod, 15 its weight, then R1 equal 15. By using substitution in R2 equals mu R1, then R2 equal 15 mu, this equation number 1. Moment at A equals 0, we find the moment at A. What is the force at 15 times AD in the opposite sign, negative R2 times OB. What is the length of AD? What is the length of OB, dear student? From equation 1, we find 15 times L cosine 30 equals 15 mu times L. By using substitution, 15 times L root 3 over 2 equal 15 mu L. Then what is the mu? The mu equal root 3 over 2. Another example. Uniform rod of weight 20 gram weight rest in vertical plane with one end of rough horizontal floor and the other end against smooth vertical wall. The ladder is inclined at 60 degrees to horizontal, given that coefficient of reaction between the ladder and the floor equals 1 over 2 root 3. Prove that the maximum distance, a mean of weight 20 gram weight, can ascend up the ladder is equals to half the length of the ladder. Solution. Dear student, look at AB, its uniform. Look at equals AB length equals to L, then AE equals X. Why? Because AM equals L, AX equal L. Then by using equation of an equilibrium, R1 equals 80. Why? Because R1 equals 20 plus 60 equals 80 Newton. Then R2 equals mu R1. By using R1 equals 80, then R2 equals, by using mu equal 1 over 2 root 3 multiply 80 equal 40 over root 3. This is reaction of R2. Moment at A equals 0, then 60 times AC plus 20 times AD equals R2 times OB. By substitution, then 60 times X cosine 60 plus 20 times L cosine 60 equal 40 over root 3 times 2L times sine 60. Then by substitution, we find the length of X, 30X plus 10L equal 40L. Then by using like terms, 30X equals 30L, then X equals L. Another example, uniform ladder of weight 30 kilogram weight rests at its upper end against a smooth vertical wall, and its lower end rests on rough horizontal ground. If the coefficient of friction between the ground and the ladder equals root 3 over 2, if a force of magnitude 10 kilogram weight act on the lower end in a direction making an angle of measure 30 degrees with the horizontal such that it acts to move this end away from the wall and the ladder was about to slide. What is the required? Find the tangent of the angle that the ladder makes with the horizontal. The ladder is in vertical plane, remark, perpendicular to the wall as limiting equilibrium. Solution. Look at, dear student, AB. It's uniform ladder. It's with 30, act in 30, act in, midpoint of AB 30 Newton. We bought length of ladder 2L, then R1 is reaction at point A, R2 reaction at point B. Look at the force makes angle 30, 10 force makes angle 30 with horizontal. We resolve 10 horizontal axis and vertical axis, 10 sine 30 and 10 sine cosine 30. Look at, dear student, equation OB and OA, x equals 0. Then we form the first equation of equilibrium, R1 plus 10 cosine 30 minus mu R2 equals 0. Then R1 plus 5 root 3 minus root 3 over 2 R2 equals 0. Then R1 equals root 3 over 2 R2 minus 5 root 3. This is equation number 1. Number 2, R2 plus 10 sine 30 equal 30. Then by substitution, R2 equals 25 gram weight. This is equation number 2. In equation number 1, R1 by substitution about R2 equals 25. Then R1 equals root 3 over 2 times 25 minus 5 root 3. Then answer is 15 root 3 over 2 kilogram weight. Moment at B equals 0. Then 30 times BC equals R1 times OA. What is the length of BC? L cosine theta. 10 times L cosine theta. 15 root 3 times 2L sine theta. Then answer 30 becomes 30 cosine theta equal 15 root sine theta. We find the tan theta by sine over cosine. Then 30 equal 15 root 3 sine theta over cosine theta. Then tan theta equals 2 over root 3. What is the value of tan theta? 2 root 3 over 3. Now we are translate to another example. AB uniform ladder of weight 100 gram weight raised at its end A on a rough horizontal round. The coefficient of reaction between the ground and the ladder equals root 3 over 4, and its rest at its end B against smooth vertical wall. If the ladder is inclined to horizontal at angle of measure 60 degrees, find the value of maximum weight can be suspended at B without breaking the equilibrium. Then find also magnitude of reaction of the wall at B in this case. Look at the solution. We have ladder AB, its length 2L, length of unit. R1, we have equation, the first equation, R1 equals 100 plus W. W weight. The second equation, R2 equal mu R1. By using R2, coefficient is root 3 over 4 R1. Then by substitution about M1, A equals 0, moment at A equals 0, look at moment at A. Moment at A, force times distance. W times AO plus 100 times distance AC equals R2 times OB. By using substitution, then W times 2L cosine 60 plus 100 times L cosine 60 equals R2 times 2L sine 60. Look at the ladder inclined with angle 60 on horizontal, BO inclined at AO equals 60. BO over AB equals sine 60. Then OB over 2L equals sine 60. Remember, sine 60 equals root 3 over 2. Then equation becomes W plus 50 equal root 3 over 4 R1 times root 3. Then by substitution about R1, then we have equation left hand side equals W plus 50 equals 3 over 4 times 100 plus W inside bracket. Then the value of W equals 4W minus 3W equal 1W equal 100 gram weight. Then R1 by substitution about W, then R1 equals 100 plus W, then R1 equals 200 kilogram weight. Also R2 equals root 3 over 4 times 200 equals 50 root 3 kilogram weight. Another example. The ladder lies in vertical plane perpendicular to the wall, and it's inclined to the horizontal with an angle of measure 45 degrees. A boy of weight equals the weight of ladder ascend up the ladder. Then it becomes about to slide when the boy cover distance equals 3/4 the length of the ladder. Remember, dear student, it becomes about to slide, the ladder becomes about to slide when the boy covered a distance equal 3/4 of length of the ladder. Find the coefficient of reaction between the ground and the ladder. If the boy wanted to complete his ascending to the top of the ladder, finds minimum force which acts horizontal on the lower end of the ladder so that the boy can do what is he wanted. Solution. Look at AB equals to L. We have R1 at point A equals mu R2. This is the first equation of equilibrium. R2 equals sum of 40 plus 40 equals 80. Then by substitution in moment B at point B equals 0, we have how many forces? 3 forces. The first 40 times BC plus 40 times BD equals R1 times AE. What is the length of BC? What is the length of BD? What is the length of AE? By using sine, cosine, tan, 45, when AB inclined with horizontal 45 degrees, find the value BC, BD. Too easy to find or to calculate length of BC, BD, also AE. Then the equation becomes 40 times 2L cosine 45 plus 40 times 3/4 L cosine 45 equals R1 times AE equals 2L sine 45. Then equation is 40 plus 60 equals 2 R1. By using R1 100 divided 2 equal 50 kilogram weight. This R1. R1 equal mu R2 from the first equation. By using R1 and mu, find the value of R2. R1 equals 50, R2 equals 80, then mu equals 5/8. By using R equals R1 equal mu R2 plus F to find the value of R2 equals 80 Newton. Moment at point B equals 0, then 40 times BC plus 40 times BE equals R1 times AE. Then we find the value of this moment by using R1 equal 60. Why? Because in this case 40 plus 80, 120 equals 2 R1, R1 equals 60 kilogram weight. By using substitution, then 60 equal 5/8 times 80 equal F, then F equal 60 minus 50 equal 10 kilogram weight. Dear student, look at another example. Ladder AB of weight 35 kilogram weight and length 3 meter raised in vertical plane with the end B on smooth floor and the end A against smooth vertical wall. The lower end B is attached by string 2 point on the floor vertically below A. Given that B is 1.8 meter away from the wall and the weight of the ladder is acting at point on ladder 1.2 meter away from B. Find the tension in the string. Also find the tension in the string when a man of weight 80 kilogram weight stand at midpoint of the ladder. Solution. Dear student, look at AB ladder act at a wall, vertical wall at point A, and point B horizontal x. We have two equations. Look at triangle ABD. ABE measure angle E equal right in measure angle E is right angle in triangle ABE, then AE equals square root 3 power 2 minus 1.8 power 2 Pythagoras theorem equals 2.4 meter. length of ladder equals 3.3 meter, but EB, its length 1.8. Then we find AE by using Pythagoras theorem. Then AE equals 2.4 meter. First, before ascending of the man with 80 kilogram weight, x equals 0, R1 equals T. Then tension, y equals 0, R2 equals 35. Then moment at B equals 0, we find 35 times BC minus R1 times length AE equals 0 by substitution. Then 35 times 1.2 cosine theta minus R1 times AE equals 0. Then by substitution about AE 2.4, then the equation becomes 35 times 0.72 equals R1 times 2.4. What is the value of R1 by division? Then R1 equals 10.5 kilogram weight. Dear student, we have the two equations before the man, which its weight 80 kilogram weight, ascend the ladder. The first equation, R1 equals what? Equals T. R2 equals 35. Then we find the moment at point B equals 0 to find the value of R1 equals 10.5 gram weight. Then we have R1 equals T equals 10.5 kilogram weight. After ascending the man, we get MB or moment at B equals 0. We find moment at point B equals 0 by third force equals 80 kilogram is weight of the man. Then 35 times BC plus 80 times BD equals R1 times AE or minus R1 times AE equals 0. Remember, dear student, we have two equations. The first equation before the man ascends the ladder. The second, when the man ascends the ladder is weight 35, the man its weight 80 kilogram weight. We find the moment at point B equals 0, then 35 times BC plus 80 times BD minus R1 times AE equals 0 by substitution. Therefore, 35 times 0.72 plus 80 times 1.5 cosine theta equals R1 times 2.4. After substitution, we find the value of R1. Remember, R1 equals T. Then R1 equals 40.5 kilogram weight. Then also the tension is 40.5 kilogram weight. In this lesson, we know that when in equilibrium, we have two conditions. The first conditions, the sum of component on horizontal equals 0, or algebraic measure of component in x equals 0 or horizontal equals 0. Also, the sum, algebraic sum of the forces in y-axis equals 0. After that, we find two equations from the first and the second. We have the third equation. We find third equation by using moment at the point equals 0 to find the unknown forces or unknown tension. Dear student, in general equilibrium, what is the condition of general equilibrium? The sum or algebraic sum of all forces component on x-axis and on y-axis, each component must be equal 0. The second condition is moment at any point of all forces as this point is equal to 0. By using the two conditions, we form equations, more equations, 1, 2 or 3 more equations to find the unknown values. Remember, when ladder inclined the horizontal and the other end on the upper wall, we have two reaction force. The first R1 equals in the right direction, also equals the left direction. Remember, when we have the ladder act on the horizontal, there is second reaction R2. Must R2 equals R2 up equals the forces down. Also R1 at right equals the forces at left. We form two equations from two R1 and R2. After that, we find the third equation by using moment at any point of all forces equal 0 to find the unknown forces. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.